Imagine, in the near future, an average day on the International Space Station. Researchers from around the globe have come together to conduct experiments in space. One young researcher is on the verge of a revolutionary discovery in his field. He is mere moments away from significantly impacting the scientific community. Suddenly, power is lost on the station. Without power, the success of the mission and the safety of the crew is put in jeopardy. Unless there is another source of energy in space, small power problems can have devastating consequences. Before the blackout can be addressed, let's take a look at how some energy on Earth is formed. A significant portion of electricity used on Earth is generated by machines known as turbines, which use electromagnetic resistance to create a charge. These turbines, which rotate to produce power, are typically driven by either wind or water. Turbines are reliable sources of power when brought in contact with energy provided by rivers or air currents, but unfortunately these energy sources are not available in space. There is, however, a little-known source of energy in space that may be able to bridge the energy gap. Now, back to the astronauts in space. Our solution is to create a machine that harnesses energy from the sun, but in a different way than traditional solar power. We propose a machine that uses the scientific phenomenon known as radiation pressure to create energy. What is radiation pressure, though? Radiation pressure is the pressure exerted by photons and other forms of radiation. The photon is a very unique particle. When we think of light, we usually think of it as having wave properties. But light also has particle properties. We refer to these particle properties of light as photons. Also, photons do not have any mass, but they do have momentum, and their momentum and energy can be transferred to anything they collide with. The momentum transferred by a single photon is minute, but we believe over time the momentum transferred from millions of photons can generate power in space. Luckily, we have an abundant source of photons in space. The sun is constantly sending off solar radiation, which, along with heat and sunlight, also provides photons. Since the sun is a constant, the power source for our radiation pressure machine would be renewable and always available. While this idea may sound very abstract, there is currently technology being tested that could be the precursor to a proposed power solution. Japan's space program tested the first solar sail, nicknamed Icarus, in 2010. Icarus appropriately stands for Interplanetary Kitecraft Accelerated by Radiation of the Sun. Icarus catches light particles with its incredibly thin, lightweight sails that stretch out to a length of 46 feet when deployed. The solar sail has been successful so far and is still continuing its journey through space while being continuously studied. We believe that the success of Icarus could be mimicked and applied to make our proposed design successful as well. How would the energy be captured from photons, though? Turbines could be driven using the same sail-type technology employed by Icarus, thus generating electricity to run life support systems with an inexhaustible source of energy. This concept would be driven by electromagnetic turbines as shown. This turbine would be housed in a stationary frame, which would consist mainly of high-capacity, long-term storage batteries. These batteries would keep any surplus energy generated by the turbines. This array, built of the most lightweight and sturdy materials available, such as carbon tubing or aircraft aluminum, would be the center of an X-shaped setup. The arms of the X would connect the sails to the center of the device. We can't test our design, so we can't actually say whether it would work or not. Today's technology probably wouldn't be able to build the turbine though. However, we are confident that someday the solar turbine or a variation of it will become a reality.